It seems okay, so we'll go through this. I'm Michael Lazar from DataArt. Thank you for the introduction. So today in the Innovation Showcase, we're going to be going through a couple of different demonstrations. Some of them will be live, some of them are recorded. And as Alan mentioned, we talked about the cloud services, telecoms. So some of these will be very practical, and some of them will be a little more interesting as far as different technologies. In the past, DataArt participated a lot with the dangerous demos led by James. And so those are very cutting edge, and they're a lot of fun, and sometimes they work and sometimes they don't. So, it really is cutting edge. What we're trying to do with the Innovation Showcase are show things that are a little closer to reality, that are usable, if not immediately, in the near term as we go through it, and that will add value to different segments. So some of the presentations we go through it will be for developers, some will be for organizations, MVNOs, enterprises, and hopefully we'll hit on a bunch of different areas as we go through it. If we run out of time, which is a very real possibility, I will have some of them available later outside if anyone wants to see them. So who is DataArt? We are a global technology consulting company. We are 20 years old. We have about 2,500 developers and consultants on staff. And I'm pleased to announce we just opened our 22nd office in Dallas, which is where I'm from. So it's going to be great to have an office as opposed to living on an airline as we go through it. And we're organized into various market segments. So I lead the telecom division of the organization. But we also have areas, and some of what we're seeing in healthcare, finance, media, IoT, and big data as well. Embedding and gaming is our newest one. So moving on, and sort of that's the end of the advertisement of the organization. In the technology showcase, we'll start off talking a little bit about the different areas and the technologies being showcased. And what we've done here is working with partners and or technologies that are available, put solutions together. And so this first solution is diskless pool computing, which may not sound very interesting, especially when we look at some of the really interesting and amazing applications that we're going to be looking at over the next 2 days, but is very foundational. And so we thought there was a lot of value add to this. So as we see people utilizing clouds, if you're using Google, using Amazon, you're developing applications, you're developing services, you want to deliver them, to test and as you're developing and to see how things will scale up and scale out and to understand the implications of how you're going to actually deploy and make these services work in the real world, it can get quite expensive, both in terms of configuration time and testing time to bring these services up online and certify them. So we'll be doing 2 different certifications. This is in our demonstrations today. This first one is really how to just use simulate an OpenStack cloud that can be run on existing cloud technologies, and where you might actually need to add or remove different compute clusters. If you think about an Amazon, it's going to be both to get charged for it, and it's also going to be a lot of configuration. So in using our different components, using a caller for configuration and hooking it into Jenkins, so it's now going to be part of your continuous integration, continuous deployment solutions. So as you're developing your code, checking it in, running your tests, it's going to all be integrated. And the idea is how fast and how quickly, of course, using containers, can we bring online a new compute node and have virtual machines associated with it? And what happens if we need to remove that compute node? Maybe we're testing failure and we don't want to have to reconfigure things. So as we go through it. All right. So with the new configurations, one of the things that's now available to us is using Cinder backend block storage, but by using Ceph, we're actually able to give a lot of interesting capabilities here. So what we're going to be doing is by deploying Ceph as the true backend, and we'll be deploying new compute nodes that actually have no storage, but will hook into the existing Ceph system that's there, be able to bring up the machines as we want, and also then kill and migrate. Kill Nova hosts that are running and do a live migration so that the system and the state and the data all stays up and running. Normally adding and removing Nova compute nodes inside of a cloud is not a very fun or trivial thing. So this is just a way to help manage it. Again, very foundational in this first demonstration as we go through it. All right. So the reality is when you're running VMs, we frequently forget, it's all just files out somewhere. It's physically backed by something. And so by configuring it this way, we're able to put the virtual machines running on a distributed storage system of Ceph, right? And then just attaching the Nova compute nodes and then assigning them and moving them as we want, right? So we use Pixie to control the booting. There are some other solutions out there that have, if you're doing your own clouds to it, but again, this is more applicable specifically if you want to bring on and test your development as you're developing a solution and need to understand both, from a testing cycle, but also from scaling up, scaling down, and failure modes, what could happen. Right. So what we're going to be doing is we'll just be showing, there's a Pixie boot server, right? So we have the key broker, Jenkins, and the dashboard on a master node, right? And we're going to add a compute cluster. And then we're going to deploy a virtual machine, and then we're going to move the virtual machine and going through the demo of what we're trying to do today. Okay. So the idea is this works both for, specifically around OpenStack, but again, this could be as an overlay. So we're actually running OpenStack inside a container and doing this. And that container can then be deployed on any infrastructure. So again, the use case for this is if you're going to be developing, deploying, testing your solutions versus, say, building. This is not an alternative cloud. This is taking technologies that are out there, using containers, and being able to deploy them quickly as we go through it. Right. So one of the things that we like about this is it really is very vendor neutral. So it doesn't matter what the underlying infrastructure is. You have a lot of flexibility to do it. And it really helps with points of failure. So using the distributed storage as it lets you add and remove your compute clusters, and just keeping just pure compute services on it, you're helping with all the dependencies that can go wrong. OpenStack has or has had, it's getting much better, but a reputation for being, once it's up and it's running, it's great, but keeping the cloud up, keeping it configured, and adding and modifying the environment, not always the easiest thing to do. And again, they've made a lot of strides in the last couple of releases, and they'll continue doing so. But this is a way to help you as you're trying to figure out if your services run in different environments. So let's take a look at it. I'm going to actually try to mirror my screen. Otherwise, I'll be turned sideways the entire time. Okay. So what we have here is a running OpenStack instance. We can take a look at our compute nodes and what's out there. Let's give you a quick overview of what's there. Nothing's currently running on it. We have some images that are available for us. And what we have here is, again, so we're running, this is an overlay. Again, this is OpenStack running on top of another system. So again, this could be Amazon, this could be Google. Just in this case, it's another physical system right here. And what we have is, we have our Cola nodes that are running for the configuration. We have Jenkins running. And what we're going to actually do here is bring up another system that will be our compute node. And you'll see that there's nothing here right now that's been backed. Instantiating this takes about 2 minutes as we go through it. So we'll bring in a new system. This is the key thing right here. We're saying do not use any hard drive on it because we'll just do the connections later. So on the system, we're going to say let's go ahead and boot off the network. We'll configure our networking. And of course, this could also be done with additional scripts to get an idea of what's going on right here, internal. We start it up. So again, if anyone's ever bothered trying to add a compute node into OpenStack, not a lot of fun again. So this is going to come up, and and what's happened is we're going to have the Pixie. We're going to be running config scripts that are linked into our Jenkins instance that run in the background. That takes about 2 minutes, right? Where we go and execute the actual build of going and adding it live into the system. And when it's done, we'll see it over here. You can see it's running it on the timing of that. So this is good. So any questions so far? I don't know, Alan, if you have some questions, because this process does take about another minute. No? Yes?
Someone who's not a developer, why is this important to me in understanding what's happening in telecom applications?
So
Michael,
as a developer,
could you repeat the question so people can hear it remotely?
Sure. So the question is, as not a developer, why is this important and what's innovative about innovative?
I've lost the thread.
And that's fair. So again, there's different demonstrations we're going to be doing. This is very fundamental on this particular one, and this really is for developers. So it doesn't necessarily, so the use case, if you're not a developer, if you're not someone who needs to do testing on your systems, not very useful, to be perfectly straightforward.
It's not about the use cases.
Right.
What have I learned? What's different? What does this change?
What this changes is the ability to very easily bring in and deploy a testing environment that can help you specifically test how your applications are going to perform on a cloud, and scalability up and down, and fault tolerance or fault results. So that's what's useful for this. So as applications come in, they're cloudified, for lack of a better term, or cloudification. The testing scenarios get very complex, and then how do you actually test how your application is going to scale up, scale out, what's going to happen for the various failure modes. If you have to bring in lots of different systems to test it that way, if you have to build out clouds to test, it can, or even if you're using services, it can get quite expensive to do it. So this brings flexibility, cost savings, and the ability to understand how your solutions are going to behave in the real world based upon the scenarios that you want to run it through. And so that's where the value is. Okay. So we can see over here, it's up. The keys have been added to it. Again, just from a configuration standpoint, we'll see right here, there wasn't a Nova node. Now there is in doing it. So again, this is something that's done very, very quickly. If we wanted to, we can go through and actually add it in right now by kicking off the script. Let's actually go bring it in, set up the compute pools, everything else. That initial 2 minutes is long enough, so I'll skip doing that for the live demonstration. But then what happens is we go through it, and we're going ahead and let's create an instance. Come back to that later. Oops. Wrong place. So here we're just specifying what type of machine that we want to run on it. Oh, see, so this is a typical, virtual machine deployment. Yes.
Adding on what you said earlier, Michael, to the gentleman second if you think about what you just did, if I was a developer or if I was standing this up on my own, it would be a 2 or 3 day process because I'm having to run in servers, I'm having to run the scripts and set it up. So instead, you did the same thing in 2 minutes. That's really a big power.
Right. I think, there's a lot of, to the cloudification of applications, how they behave is, how they're architected, first off, so there's the development side of it, but how they behave in the environment is something that frequently doesn't get thought of enough. And it's a very complex testing matrix when you want to scale, if you want to move it, what have you. So this is fairly quick when it's doing it. I love going first. It shows, so things like resolution on the screens always get interesting. Okay, so we can see the instance is up and running. Its IP address is 08. Ah, okay. Of course not. It's an interesting time, so what I'll do from here is we can see that in this particular machine. We'll come back to this later. We have quite a few to go through. But one of the things I can tell is what host it's running on. And which host is this one running on? Oh, thank you. That's the other screen. The third one? And so we see it's running on here, it's running on host 04, I believe. Right, so it's running on 104, which is this guy. And what we can do is then it's this one. As you can see, so this we have the name here, so we see it's 104, and I can literally just come in. And power off the host. So remember, we have a virtual machine running on it, right? So I come in and I actually literally just kill the host that it's running on. Right, and so now what we can do is we can do a host evacuate, and we'll change. Let's see who's up. So 204 is up. I believe I have the order right there, right? So it's the. So if you think about what normally happens, if you think you have a hypervisor and you kill the hypervisor with a running machine, generally not a good thing to have happen, right? You'll kill your running virtual machine. But by using the Ceph-backed storage and making it a diskless pool, what we've been able to do right here is, since everything in the virtual machine is really just file, right? It's written as a file, and that's a shared storage system behind it in Ceph, kill the compute node and just seamlessly migrate it over to virtual machine. So we didn't lose anything, able to move things around, so that would be a failure mode test. You can't do this with a lot of typical implementations of a storage and a Nova compute node. So again, the benefit here is being able to quickly bring up different scenarios, different failure scenarios, and test your applications and see how they're going to behave in the cloud. Right? So that's it for the demo, because again, all we did was we talked about what it was, but we brought up a host, we brought up a Nova node, instantiated a virtual machine, killed that host with the running virtual machine, and then still migrated it. Right? And so that system is still accessible and running right now. So any questions on this one? Just in the interest of time, we'll keep moving on. Yep.
But Harold made the key point that this is taking, what used to take days, really down to minutes. And this has been a theme we've had within DataArt Summit for quite a few years. Back in 2014, when we showed IMS in minutes, we were stretching things a little bit when we were sort of spinning up the RESTCOM server and I can't remember, Clearwater IMS platform. Mm-hmm. But again, this is taking it to the next level now. So it's a whole environment is getting spun up in minutes. There are certain operational features within this as well, in terms of performance and scalability and the price points that I think make it very interesting. But I'll let you now get on to the blockchain billing one, because I think this is very interesting. So
again, the first one is very foundational. In some ways, maybe too basic, but we think it's very important to understand that as we're moving and doing things in clouds, there still has to be that basic blocking and tackling of manageability. And there are solutions out there, but there are not a lot of great solutions, and they're not necessarily thinking about it from the developer's perspective. So that's why we wanted to show that one. This one's a little bit higher level, I think, as an application, and this is finding a good use for blockchain technologies for payment services as we're going through it. So some of the partners and technologies that we're using right here. So of course, RESTCOM, using Ethereum, Ryden, and then technologies from the REST APIs, WebSockets, JSON, and then have the ability to do Google and IBM text-to-speech engines. And so this is actually going to be comprised. I'll bring up Alexi to talk about it in a few minutes. Alexi, I'll just bring up in a few minutes if you want to wait. When I get to the demo part. So just assuming, because I think everyone in this room has some familiarity, at least conceptually, with blockchain. So I'm not going to, we're not going to really go into a full detail of what it is and why it's important. But the idea is that you have a distributed ledger system. It can be used for distributed ledgers. It can also be used for proof of work. So it's not just about anonymity in contributions for a transaction, but to verify the transaction. You can also use it in terms of proof of work. right? So there's different ways of implementing the technology that's out there. But the idea is, as opposed to a central database, right? From a transaction perspective, you can have a distributed system, right? So again, very basic introduction if you're not familiar with it. And again, just the idea that there's, again, on the blockchain side, the idea that there is going to be a medium of transmission. There's going to be some computing resources, both from sending and receiving. And again, this distributed ledger and information and coordination that goes back and forth on it. And the demo, and what we're talking about here, is not intended to be about blockchain itself. It's about being able to use blockchain for payment services. And you're doing it. So speaking of it, one of the important things is when you have, what is a simple way from as a provider? So if you're a CPaaS provider, if you are a telecom, and even if you're an application developer, how do you hook into the telecom infrastructure from a billing perspective, all right? So this, and what we'll be showing and talking about here, is one way that sort of allows you to come in and do near instantaneous payments and also near instantaneous receipts of payments, which is just as important, getting the money, and being able to really abstract what's sort of underneath it. So you don't have to worry about diameter configurations from a telco. If you want to approach a telecom as offering a service to it, this is a method that could be added on top of it, and again, hide the complexity of typical telco billing underneath it for a service. So again, lots of different areas that it could be used for, but I think the most important thing is it can be done as a very efficient billing system. Ethereum's little problem earlier this week, or last week, I guess, right? Several $100 million of transactions are locked up. So it's still an emerging technology, but the fundamentals behind it are pretty sound. And remember, Ethereum is the ability to, as a technology, unlike, it wasn't done just as a digital currency. It was done so you can actually buy, use, and consume computing services, right, in very small increments very quickly. That was the idea behind it versus like a Bitcoin, which is currency. It has a currency component to it, with Ethereum, of course, but the idea here is that this is how you can attach and purchase a service, offer a service, and hook into pretty much any underlying billing system underneath it. And so I think that would be very relevant for, again, whether you're a provider or a developer or a user. So again, as opposed to the first demo, I think a little more useful for some of the people in the room on doing it. There's a big issue, obviously, in telecom and NFV, which we'll be talking a little bit more both later today and a bit on tomorrow. So how can you use it for data integrity and protection as well, and all that. So what I'd like to do is I'm going to call up Alexei, if you'd like to come up. He's going to walk you through our architecture and demo. I get to take a break and get a glass of water. That's fine. So the video's at the end.
Thank you, Michael. Okay. Actually, when we started this work, we just wanted to touch this technology and to understand if it's possible to use it and apply in the telecommunication industry, because at the moment we know that blockchain and cryptocurrencies have some sort of limitations which came from the essence of blockchain, distribution nature, and necessity to process every single block. That's the problem. It costs an actually quite huge amount of money, depending on the cryptocurrency you selected. And we tried to play with that and finally found a very interesting way. So we started with RESTCom, an open source communication platform. We implemented some wrapper around the MIDI server and another one around the speech API. We tried at least two of them, and finally decided to use Ethereum blockchain trying to implement a few smart contracts and decided to move to the new emerging framework, which is called Ryden. That's an interesting stuff because it allows to overwhelm the most difficult limitations. So in our scenario, RESTCOM media server is going to pay tokens or ERC-based cryptocurrency invented for this demo for every single word recognized by speech API. And at the moment we are running on the test networks. We tried 2 of them, Cowan and Robston. Cowan is more interesting and reliable. Robston is also useful. So Ryden processes the payments and acts in some sort of billing system. Ryden is an open source payment channel framework. You can check it in the internet. Just announced their ICO, very interesting stuff. It is some sort of complementation to Ethereum blockchain, helping to overwhelm most of the limitation. And the idea behind the Ryden is to establish the payment channels for the frequent payments. Trying to be concise. Actually, the heart of this payment engine is micropayment channel. In Ryden, it could be bidirectional. We selected to use the limited framework, which is called Ryden, and this is the set of unidirectional payment channels. It's managed by smart contract. And most interesting, we don't need to transact every micropayment on the blockchain. So calculation and gas price, so the cost of the payment is being done only on the channel level. We have some sort of deposit mechanism, and these deposits are working like some kind of prepayments and security for the consuming services. We are also not limited in terms of number of channels established, so everything depends only on the balance of the sender and receiver. About senders and receivers, I have next slide. This is the process. We have 2 parts, sender and receiver. Each one has wallet. Wallets are connected through the Ethereum blockchain network. Ryden provides the smart contracts for that. Sender is going to establish the channel to the receiver and deposit certain amount of tokens to supply the future consumption of services. When receiver processes this request and provides the service, it generates check. Check ensures that everything is fine and receiver is ready to pay. This is repeatable process, and the only limitation is lifetime of the channel and the number of tokens we deposited. Right after a receiver decides to close the channel, Ryden will calculate the total amount and transmit the virtual money. I will skip the implementation part. Actually, we developed 3 wrappers, and communicating between them established this payment. So I would prefer to show the video because latency of the network and the fact that we are working on the test net drives us to this.
Go down to the video itself.
Uh-huh.
There it is, flag.
Okay. Hope sound is switched off. Okay. User interface is quite simple. We have just 2 pages with the balance of sender and receiver. We have certain number of tokens available in our artificial coins and in the Ethereum, because we are using Ethereum to pay for the transactions. So we should track that. We have channel ID, we have deposit, and to imitate the start of the service consumption, we need to press the open channel button in order to make sure that service could be provided. Then we are using Xlite to make a call on the RESTCOM and engage the speech recognition. So calling the number, speaking certain number of words, and registering the transaction. Each word costs 2 tokens. Okay, service is consumed. Then we see that receiver has the checks for these words. Actually, we can we are opening new channel and again trying to consume some services. Getting closer to the final check and helping receiver to monetize the services provided. So everything is done by means of this user interface in order to keep the demo demonstratable. I will cut the way. Not possible. Okay. So we see that receiver has received another bunch of checks on the new channel. The most interesting part is that both sides are controlling this process by means of events. So if sender opens new channel, this is the sign for the receiver that he or she can monetize the tokens accumulated in that. And this is being controlled by micro Ryden. So actually we are waiting for appearance of the button close the check on the receiver's page. This is blue button, which allows receiver to monetize everything collected so far. And right after that, balance is changed. So receiver is getting richer. Sender, I hope, will soon saw. Well, this is about the visual side of the process with the help of some sort of user interface. And here we have the explanation of what's going on. So we are starting with a certain amount of tokens in the pocket. We are opening channel number 1, depositing 50 tokens in that. Balance is decreasing. Then we are starting to consume the services using the first payment channel and saying one word and then saying 2 words. So balance is decreasing. Then we decided to establish new channel. Notice that amount of money is not decreased because we provided the deposit on the first channel. Then we are deciding to close the channel number 1 and to sign the check. So Ryden is doing reconciliation of balances, calculating the total amount and transmitting the certain number of tokens consumed from the sender's wallet to receivers. Questions? Actually, speech recognition is a little bit different side of the story. This is, I wouldn't say that this is the focus of this demo. Focus of this demo is, of course, micro payments, but speech recognition is also not the big deal. We can use public available APIs. We can use engines. We can use, for example, Google Speech API or IBM Watson. We will see it in the next demo, which is dedicated to the chatbots. So they have very well explained API. They have trained network behind. We can also use, by the way, open source stuff like TensorFlow, for example. Last year we demonstrated the Mask Buster demo, which was done on the TensorFlow network. And the only limitation of TensorFlow is that you need to train it enough to make it capable to recognize everything you need. So at the moment, Google, IBM, and Microsoft are more or less upfront of all the other parties, but actually I'm expecting emergent new providers that could create their own speech-to-text or text-to-speech engines. So in our case, this is just an integration using WebSockets and using JSON, nothing more. Most interesting is how to make Ethereum work in micropayments mode.
Thank you. So again, on that, the idea is that this can actually hide a lot of the complexity of different billing systems, and it can be applied to different services. We'd picked one in particular, but the idea is that it can be extended to anything, and that, again, that's the value that we saw in this particular demo and technology. So I think between last year, every other show that's out there, we see a lot about bots. I think that's important. But we have 2 demonstrations here, just sort of again, it's showcasing certain pieces that we believe are interesting of technologies and how they can be put together. So for the first one, we're showing some CRM integration with bots. I think the most important thing about it is in our CRM systems, or especially if we make publicly accessible bots, there might be different levels of sensitive information. And so using Tintech, being able to do multi-factor authentication when certain aspects of information are accessed, which I think is very, it's different and important. And it gives control back to, if you will, to allow more access or deeper or richer access, but still put controls on what type of sensitive information and when it can be accessed. So I'll give you some examples of that. And so again, I think we know on the virtual assistants, we've seen them in the interest of time, right? So the idea is that it's doing language processing to figure out and parsing it and coming back. There are scripts that are conducted for how it needs to work, right? So there's lots of different ways. So we can do it from messengers, SMS. We can do it from voice calls, DTMF menus. And the idea is that the information get accessed. IoT obviously has a big role to play in this as well. And so the idea is that this enables, this is enablement to allow someone to consume your technologies, interact with your technologies, and not necessarily incur the cost of having people supplying information, answering the phone calls, but using technology to do it. So it scales, it's rapid. But again, sometimes there's, pieces of information you may not just want to give out that may be accessible so you can control it. In the first demo on this. So again, we can ask complex questions. Again, this is per se on the chatbot itself. The purpose of this particular demo is not necessarily around educating everyone on chatbots. There's an assumption, especially with the people in this room, that they know a lot of this. But we'll have this, and these slides, of course, will be available on it. But there's filtering, trying to make sense of what the question is, asked and answered in. Right, and then there's the actual integration. So you have to accommodate multiple channels to get to the same information or result out of it. And you have to allow the rich queries. And I think that's very, very important here is, again, having security that can now be added in or layered into these chatbots. Again, Tintech was very helpful with this. Right, so in this case, we can do an integration with the CRM system, so using Salesforce. On the back end of this, and again, there could be a lot of information in Salesforce that you wouldn't necessarily want just given out, versus some information which is fine to give out. And so again, the demonstration, the purpose of this is being able to set and control and configure where the access goes. All right. Another area about this is on the gender API, which is really interesting, is keeping track of the question in the query, especially when it comes to as we'll see in a second, who is Arthur Clarke, and then what is his phone number, versus saying what is Arthur Clarke's phone number. Right? So it may sound, again, if we're as human beings, it's very simple to keep this information. On chatbots, not necessarily so simple, because you have to keep the reference of what you're talking to. Right? So again, as an integration, putting this together. Right, and then what we'll see right now is then we'll do a security audit. So it's easy enough to get Arthur's public phone number, but maybe doesn't necessarily want his mobile number given out. So we'll kick in two-factor authentication to show it. Once we do that, we'll get the information. So assuming, it's always a fun assumption that this is going to work. Okay. We'll see when it pops up in the ad. So I should sort of this and do it in order. So we have a CRM channel, a chatbot that can be subscribed to. We're actually doing this on the phone, assuming it's going to work. All right. So we get back a response from it, and then. So again, it seems simple. What's his phone number? But again, now we're relating the gender back to the person we're talking about. So get back the phone number, right? And then since no one ever answers their phone anymore, you want to call it mobile, right? So again, this is a very specific example of saying that this is something that's sensitive. Hopefully, I go and you can see my verification code has come in on it. So this can be adapted in several ways. But the idea is that now I can start doing some classification and information and verification of users. So we believe this is very extensible, right? And this will take the concept of chatbots to the next level, and it could be, you could prompt and interact and authenticate as you see fit and need. So now I actually have poor author's mobile number, so now I can really bother him whenever I want in doing it. So again, I'm going a little fast here to keep us on schedule, but contextually, I don't think so. Any questions on that? And again, the showcase here is really on the putting in security into the chatbots when you're starting to access what you believe is to be different types of sensitive information.
Got a question, Michael.
Sure.
Within the chatbot, would the security be baked in? So it's something that's part of the chatbot client, or is this something that would be provided as a service?
Well, I think it's a really interesting question. I can't remember the name of the company we were talking about it earlier, but there are, if you want to...
Payphone.
Thank you. So there are organizations, so this can also be done as a service. So as opposed to needing to do this and maintain it yourself, the ability to integrate in with an external service and have it. So the question is this really providing a lot of extra value? Yes, do you need to maintain the infrastructure and the security infrastructure, and do you want to control that? That may not be so valuable, right? So this also has implications, especially here in Europe, with the privacy policy protection. So saying, nope, I've now outsourced this, and they're responsible for maintaining this and keeping the logs and records of, yes, they authenticated, yes, they were authorized to have access to this information, right? So it can be done and implemented in a couple of different ways. The second part of this is, right, is taking technology again on chatbots and implementing with healthcare, telehealth. As I mentioned, DataArt's very involved in different areas. One of them is in the healthcare. Obviously, something like healthcare, you have it's a highly regulated environment. There needs to be good records kept, similar to financial transactions, right? You can't just have a conversation and not document it and not have it stored in a secure method. So in this case, we're using, again, the technology is just being showcased here. So we have WebRTC, .NET, using Watson. Again, there are different technologies that are available here. Health Navigator and other, and speech-to-text engines used for logging on it. So the idea here is, how can you come in, right? Getting some details, asking some questions. So this is again to us again the purpose of this is not so much saying this is a telehealth solution. This is about the technologies that are driving it. And an important one is being able to log, take the conversations. Multiple media, meaning that there could be interactive responses, right? So selecting something, as well as providing information, and all of it getting logged in a way that's going to meet compliance needs, right, as we go through it. So again, this is we actually from a couple of years ago we had a sponsor or as a showcasing in TADHack. We saw a lot on telehealth. So this is very interesting that's been put together. And we'll allow this one to play through. Do we have audio on this one? Is the audio enabled? Hold on, make sure we have audio being sent out. This should be playing through, so.
Is there anything else? Well, I ran out of my inhalers.
There we go.
Sounds like you're worried about this.
Okay.
Good morning. This is Telemedicine Doctors, Joe Foster speaking. Can I help you?
Hi, this is John Gomez. Can I speak to the doctor, please?
Absolutely, John. I'd like to ask you a couple questions first. Please tell me your main symptoms or problem.
I have some wheezing and cough. Feels like an asthma attack.
Is there anything else?
Well, I ran out of my inhalers.
Sounds like you're worried about this. This is an asthma attack.
Yes.
Do you have chest or rib pain?
No, I have no pain.
Are your lips blue or are you looking pale?
No.
Are you having trouble breathing?
Yeah, I'm feeling a bit of a short breath.
John, thank you for telling me about your symptoms. I'm sorry that you're feeling sick. This type of problem can be an emergency or serious. Please stay on the call. I'm going to connect you with one of our telemedicine doctors right away.
Right, so here you have a couple things going on, very quick presentation on it, but so in a chatbot scenario, you have, again, questions. So things that could be improved on this is adding things like facial recognition from TensorFlow, parsing out the video stream, so not necessarily needing to have, are your lips blue, because you can see that. But I think what's very important about this is you have dynamic content based upon the feedback, and it's all being logged and recorded, so after the fact, the doctor can have it. There's a transcript of the conversation, right? A transcript of the person responding to the questions. And again, it's not just the voice side, but it's also the ability to add in this case, that there were actual questions and pieces picked by the person on the call. And that gets put together. And then this is the idea helping to meet compliance, right? And that's, again, from where we think the technology is going and sort of what's becoming possible out there. So any questions on this one? No? And thank you for Rescom, Johnson, but for, again, on the using a lot of the technology here behind the scenes, and for everyone else. So this, again, is just sort of ideas of what can be done with these types of things. And again, this obviously has commercial implications, right, if this is your market. I'm going to go through this next one very quickly, just highlighting it. This was something that was shown at Mobile World Congress as well. And as telecoms, so who this is most interesting to is providers, quite frankly, and sort of the use case here versus developers. So sort of a different side, or although it could be somewhat applicable to them. What here is with everything that's been going on in telecom, and I'll come back to it, I want to say thanks to our partners first on this. So Ixia was kind enough to lend us some of the components necessary to do the testing of the applications and services. And also, so they have different products. That we're using the IXLoad Virtual Edition to do this. And we're also, as DataArt, we are part of the Etsy OSM Open Source Mano group. So we're actually using open source Mano as a orchestrator to deliver this service. So, and of course we have our friends at Canonical using some Juju out of this as well, and CloudInit. And now we can turn that off, because that'll be annoying. Okay. So sort of what's going on here, and why is this on presentation? Sorry. What's interesting, so very quickly in telecom, if everyone doesn't know, telecom has been embracing virtualization. But of course, being telecoms and providers, they don't just go out and do what enterprises have been doing. So they're following a path called Network Function Virtualization, NFV. And very shortly, NFV is all about going from proprietary hardware and software to commercial off-the-shelf solutions and open solutions. Open solutions do not necessarily mean open source. It just means that things are published and documented. And then the things that run on top of this virtualized infrastructure are called, again, because it's telecom, we can't call them virtual machines. That'd be way too easy. And they're really not, but they're virtual network functions, so VNFs. But the idea is now when you're taking functions, say, a carrier-grade NAT or firewall or VPN tunnels or any other services that telcos may want to provide, how do you test them? Right? So now that, in the old days, it's somewhat simple in that you had this big rack. You didn't have issues with noisy neighbors. The rack did a function. One cable went here, another cable went there, and the service could theoretically become live. Now that it's all moving towards software, right? Now you have complications of how it's instantiated. How do you bring up a service? How do you know what the service will, how it will perform in a virtualized environment? How do you do maintenance on it? The concept of doing a 2 a.m. to 2:30 a.m. Friday change window goes out the door when you start having, commercial off-the-shelf Linux solutions, as your underlying virtualization. I don't think, the addressing the problem of how would you patch and update a system, when a critical vulnerability is discovered. You probably aren't going to want to wait, 6 months for the change control. So these issues get kind of interesting in what you're doing with that. So, and then how will, of course, the services, these virtual network functions and the NFV be impacted when you're bringing things up, putting things in the maintenance, patching things. And so this process is generically called like VNF verification, VNF certification. And so what we've done is put together a solution leveraging open source Mano, leveraging our good friend OpenStack, with technology provided by Ixia, which is actually helping to automate the testing of the VNF. So it's VNF verification, and again in telecom language, as a network service. And so this is all about enabling telecoms to be able to look at a vendor's VNF, bring it into their lab, certify it for use in their operating environment. The idea, again, with the telcos with NFV is that instead of buying from a single vendor, that telecoms will be able to buy from multiple vendors in order to deliver a service. There should be cost savings, but also a lot of flexibility. And in order to do that, you have to verify interoperability, you have to verify its performance characteristics, and how it's going to behave itself. So it's actually a pretty complex issue in doing it. So what we're going to be doing here is just deploying it. I'm not going to go through everything, just in interest of time, because there's one after this I think will be more interesting for the audience as well. But I'll show you pieces of this. And so the idea is that we're going to actually instantiate a session border controller as a VNF, which would be a popular use case, and it's one of the more complex ones. Then we're going to actually use Ixia to automatically test it. And the idea, again, is that you can bring in different VNFs and see how they perform and have reproducible history, reproducible characteristics. This could also be used when you're bringing on a new service, or if you're transferring from, say, data center A to data center B. And so there's lots of very specific use cases where service like this is useful to an operator. Right? So interestingly enough, we're actually seeing not just telecoms, but truly, the cable operators and other people just about providing content expressing a lot of interest in NFV out there. And again, the idea is just cost savings, time to market, and avoiding vendor lock-in. Right? So I think are things that a TAD Summit and programmable telecoms you can all agree with. Very, very important. So telecoms are getting there. They just kind of move at their own pace. But they are definitely moving there. So the idea again is, they're identifying bottlenecks, identifying where they are, and identifying the performance characteristics, and most importantly, being able to reproduce this, right? So being able to run this test not once, but 100 times under varying controlled scenarios, so a telecom can understand, yes, I want this bit of technology in my lab, or sorry, out of my lab and in production. Right? So here, by using, again, from Ixia, the IXLoad Virtual Edition, they have breaking point from security testing, but the idea is we can actually, when we're bringing up a service, test it end to end, and actually simulate and actually bring in traffic that looks and feels like end user services. And so again, the operators can get a real feel for what's really going to happen. Again, so lots of different controls on it, but the idea is that it's real world simulation. For the testing, and reproducible in doing it. So the testing architecture we're showing today is that we have the open source Mano, which can instantiate the service, and then run the testing and then provide the results. So, and again, just in the interest of time, because we're running out, Alan's kind of looking at me, so we will go forward. So I know this will be shocking to everyone in the room. Telecom architectures can be somewhat complex. I know, no one ever understands that. But on a serious note, so trying to just the instantiation of something like this, of a network service, is complex on its own. So that's one of the reasons that you have orchestration, right? So in Mano, they'd be able to bring everything up, set up all the interfaces, set up the the networking, and then set up the configuration inside the VNF, so the software itself. Automating all of that is a huge benefit to anyone who wants to consume this type of technology and going through it. Right? And so once that's done, again, this is the SBC example we're looking at. So once everything is brought up, instantiated, then we can actually start running test traffic through it and see how it works and behaves. And again, for the provider, getting that information back. So what that looks like in the real world. No, don't go to sleep. So again, in the interest of time, I will skip through doing all the steps here, but I will walk you through them very quickly. So what you have is a network service. This is a screenshot of open source Mano. And what we're doing is we have the network service descriptors and then the VNF descriptors that are over here. And you can see Ixia. And then the various components that get configured and the various configuration options that go with it. And the idea is, again, that it can just simply be executed, right, by being able to select it and then brought on to work. So what is typically, a very complex process to bring in, deploy the services themselves, configure the services, test the services, and then view the results, is now can be done in an automated fashion, and multiple VNFs can be brought in and tested. So you, as a telecom operator, you can choose which one that meets your needs, right? And then if there's a new version that comes out, or a patch, or an update, you can actually review the results, and the results look. That would be a window within a window, probably a very bad idea, right? So then the results come back on a session border controller, as an example, and we just ran this one earlier. But the idea is that you have a test bed and it tells you where there are potential problems and breaks down to the very specific points and issues through it. Right? And so this information gets fed into a database, and then you can have your history as you're going through it. Right? And so again, from an operator perspective, very, very useful and interesting. I think we're out of time. There you go. Yes, please.
How would you compare OpenStack to something like Kubernetes? Do you see this complementary?
Different use cases. So OpenStack is an infrastructure, right? So you have a very defined cloud infrastructure, Kubernetes as a container that is very useful for lots of different things, right? So the containerization provides lots of benefits. It can certainly run on top of OpenStack. Matter of fact, we used Docker in the previous example, but that's just not exactly the same, of course, but another container type technology where it can be layered on top of different infrastructures. So Kubernetes really helps you do lots of things. You get quick, you get fast, you get some degrees of scalability that's built into it automatically, and lots of control. So to me, on the containers, it's finding the right one that fits all of your needs and that you believe in and you think is going to be a viable technology. I think there's a lot of them out there. OpenStack is, I view OpenStack as it's a leading contender for network function virtualization, but it's not the only game in town, but telcos seem to have adopted it. And it's a very strong and reliable cloud architecture. So it's more, if you will, fundamental than Kubernetes, and that you build on top of, but Kubernetes runs in many environments. So I hope that answers.
Yep, no, that's great. So please, a round of applause for the hard work that the DataArt team have put together over the past 6 months now, isn't it?
Yes, we did run out of time. If anyone wants to see it later, and again, if just to mention it, because it's also that one's also a video. It runs about 11 minutes. But we've also found for developers, again, being able to test their applications from a device perspective. There's lots of tools and technologies out there that let you automate your mobile device testing. You can subscribe to a cloud service offering and test it on lots of different things, but we've actually built and again integrated on a set of technologies. We can test it on specific devices and see the differences from that the device itself is introducing into the way your application is behaving. So if anyone wants, for the next 2 days, we're here. You can see it at any time. It's just a recorded video. Just want to offer that. I think that could be very interesting, and we will publish it as well with the
exactly. It'll be up on the TAD Summit site when we do the big review. So what we're going to do now is we're going to take a break.